All right, so both of these questions use different properties. So this first one has addition. And what are you going to do when you see this on the test Friday? When you see two logs being added, how do you condense addition? Multiplication. Good job. So we're going to multiply 2 times 4x squared. So addition condenses to multiplication. So that would be the log base 8 of 2 times 4x squared equals 1. All right, so now what are you going to do? There's only a log on one side, so how do you do that?
8 to the first power.
8 to the first power. So yeah, we're not doing the notes just yet. We have some bell work to do first. So you would rewrite that as 8 to the first equals 2 times 4x squared. And then 2 times 4x squared is 8x squared. And 8 to the first is 8. All right, now what do you think we're going to do?
Square root. Divide by 8.
Divide by 8.
That's your nails done.
Oh, yeah, last week.
I bit off successfully over the weekend.
Oh, okay. So then you have 8 divided by 8, and you get 1. So 1 equals x squared. And then what are you going to do? Take the square root. Now here's where most kids go wrong, because what is the square root of 1?
Plus or minus.
Oh, plus or minus 1. There's 2 answers. Now, will they both work though?
No.
So if you take, so this is what we have to test it in. We have to test it here. So if you take 4 times negative 1 squared and 4 times 1 squared, are they both positive, or is one of them going to be negative?
One will be negative.
Both are positive, right? Because what is negative 1 squared? Positive 1. So we actually have 2 solutions, and they both will work. All right, go ahead and copy down the second one. So our second equation has a subtraction sign. How do you condense subtraction?
Division.
Divide.
With division, good. And when you do that, this is in the numerator, negative 3x minus 1. And what comes after the subtraction sign is in your denominator. So that'll be the natural log of, and then you have negative 3x minus 1 over 7, and that equals 2. All right, what is the base of a natural log? E. There is an invisible e here. So you're going to rewrite this as e to the power of 2 equals negative 3x minus 1 over 7. Multiply both sides by 7. So that'll give you 7e squared equals negative 3x minus 1. Your next step is going to be to add the 1. So that'll be 7e squared plus 1 equals negative 3x. And then lastly, you're going to divide by negative 3. So this is your exact answer. Will be 7e squared plus 1 divided by negative 3. And if you only left it that way, that would be fine. Go ahead and practice typing that in your calculator. Then I have an extra calculator. Does anybody need a calculator? Zion, you need a calculator? Sawyer, can you pass that back to Zion? All right, so when I typed this in my calculator last period, I got negative 17.574. Okay, can we keep that answer though? So what you want to make sure is if you put it right here, if you take negative 3 times negative 17 minus 1, what is negative 3 times negative 17 minus 1? Is it positive or negative? So that means we can keep it. And I would take either one of these answers, this one or this one. Okay, so now we're going to start our last part of chapter 5. We're going to do the majority of the notes today. We'll probably save the last question for tomorrow. I'm passing out your test review tomorrow, and your test is on Friday. So here is the homework for your last homework for chapter 5. It's only 6 questions, very short. It's all word problems, and it's due this Thursday. I believe so, but I don't really. Okay, I don't know. I have to check Canvas.
Homework 22 is
Which
due
one are we
today.
on? We're on homework 23.
We're on homework 20.
Oh, so I need 22.
22, 23.
Well, 24. They're all. I made them pretty short. So this is only 6 questions. So. All right. So let's get started. Go ahead and copy the value. So we have 2 different formulas for compound interest. This is our first one. Okay. But this is the second one, PERT. We only use this one when it says compounded continuously. That's the only time we use this second one. All right, so take a minute and copy down what the variables represent. A is your ending amount. P is your start amount. R is your rate as a decimal. N is the compound frequency. And T is the time in years. So we have different N values for this first one that we can use. The first one is compounded annually. If it's compounded annually, that means that N equals 1. If it's compounded semi-annually, what does that mean? 2. What about compounded quarterly? 4. Nobody said 25. That's what most people say. They say 25 because a quarter is 25 cents.
He says that.
Monthly, 12. What about weekly?
52.
Wow. And then daily. All right. Most times, next year it'll be a leap year, so it'll be 366. Okay, so let's go ahead and jump in. Pick up a calculator if you don't have one. You need one for today so you can practice typing these into your, typing it in to get the exact answers. All right, so let's look at example 1. And I actually put the formulas there. Of course, they won't be there when you take the test. Well, the formula that you'll have to use won't be there, I meant to say. So you have to know that it's the first formula, not the second formula. So it says if you deposited $7,000 into an account that pays 8.4% interest compounded monthly, how much money will be in the account after 4 years, provided you don't make any additional deposits? So we know that my starting amount is $7,000. Now the interest rate is not 8.4. You have to divide that by 100. So if you take 8.4 divided by 100, that's the same as moving the decimal 2 times to the left. That would be 0.084. It's compounded monthly, so N would be what? N is 12. And we want to know how much will be in the account after 4 years. So you're just going to type this directly into your calculator. So you have 7,000, A equals 7,000, 1 plus 0.084 over 12 to the power of 12 times 4. So take a minute, type that in, practice typing it in. It should look exactly the way it's written on the screen. That's how you type it in. And we're gonna round, because it's money, we're rounding everything to the tens place. So 2 decimals, 2 numbers after the decimal. So this is what you should get. So make sure that's what you're getting. If you're not getting that, raise your hand and I will help you. All right. Any questions about the first one? Who had that answer in their calculators? All right, so let's look at our second one, example 2. So now it says you have $5,000 into an account that pays 2.9% annual interest compounded continuously. And that's why we're switching to PERT. How much money will be in the account after 10 years if you don't make any additional deposits? So now my starting amount is $5,000. My interest rate is 0.029. Remember, you're taking that percentage, dividing it by 100. And we want to know after 10 years. So in your calculator, you're going to type in 5,000. You have to hit second function ln to get that E. Go ahead and type that in, see what you get. Who got $6,682.14? All right, any questions about how we did that? All right, take a minute and try to do number 3 by yourself. All right, who got the same thing I got? $5,173.08. So we had our initial deposit of $3,000. Interest rate is 0.061. Time is quarterly, so quarterly n equals 4, and t is 9. All right, I did make a slight change to example 4. Yes. So we're following this formula. So the formula says R over N. Oh. So you have to change it percent as that number percent has been multiplied by 100. So we want the rate, which is what you would get before you. We want to convert it back to decimal. All right, so I did make a change in example 4. Can you change that to continuously instead of monthly? Okay, so it says that at 2.35 annual interest compounded continuously, how long will it take to double your money? So they didn't really tell us how much we started with or how much we ended with. Exactly. And this time we're trying to figure out how long, so we're trying to find time. So I changed it from monthly to continuously because if we were doing monthly, we would have to use the other formula. So continuously tells me I'm using PERT. So my ending amount, it really doesn't matter what you use for your ending amount as long as whatever you end with is double what you start with. So how about we say we started with $1. If I start with $1, if I want to double that, that means I'm going to end with what? $2. Now again, you can use anything. You could say 50 cents and $1. You could say $2 and $4. I'm just making it simple and saying I'm starting with $1 and I'm ending with $2. My interest rate, we have to divide that by 100. So take 2.35 divided by 100, and that's what you should get. And I'm trying to figure out what is the time. So let's go ahead and substitute that all in. So 2 equals, now because I picked 1, I could just drop that and say E to the power of 0.0235 T. What's the opposite of E? What's the inverse of E? ln, natural log. So we're going to put in a natural log on both sides. Not a common log. We want to cancel out E, so we're going to put in a natural log. Natural log on both sides. So when I put in that natural log, this cancels out. And I have the natural log of 2 equals, so now that is no longer, that's no longer a exponent. It's come down. So what's my last step to solve for T? Divide, because they're being multiplied. This cancels out, so go ahead and type this in your calculators. And we're going to round to the 10th place. So type in the natural log of 2 divided by 0.0235. And you should get a T is approximately 29.5 years. So when you see this on the test, if it doesn't say, it says double your money. So you pick the start and make sure the end is double that.
So for ln e,
Natural log of E.
natural log of e. So when you put the natural log beside the e, you just cancel out the e, but you also cancel out the natural log.
Right, so because they're opposite. So the natural log of E is actually equal to 1. So you have to kind of go back to what natural log. A natural log is a log base E. So if you take the log base E of E, what I'm saying is, you got to remember, what is a log asking you? It's asking you, what is the exponent on E that I need to get to E? And that would be 1. So for example, if you take out the E, because that could be what's confusing. If you say log base 3 of 3, or log base 4 of 4, or log base 10 of 10, to get from the base to this answer, the exponent is 1. So this is actually equaling 1. And that's why I canceled it out. Because this is 1. So this becomes 1 times the interest rate times T. Okay, let's look at example 5. Example 5 is a little wordy. So let's go ahead. Let me zoom in a little bit. Okay, so the first part is pretty easy because it's asking you to find the balance. So Nevaeh deposited $5,500 into a savings account that earns 3.7% interest compounded monthly. Use the formula to find for compound interest to determine. So the first thing we're going to do is figure out the amount of money in her account after 9 years. So that means that we're trying to find A. For this first part, we're finding A. So A is going to equal, and it would be 5,500, 1 plus, and then the interest rate is 0.037 over, if it's compounded monthly, what is in 12 to the power of 12 times 9. So you just type that in your calculator. But the second part, so you should get $7,669.38. Anybody else get that number in their calculator? All right. But part B is saying find how long it will take to double her investment. So now we're trying to find T. So in order to find T, if I want to double it, that means that the A is what? So she starts with 5,500 and she wants to double it. How do you figure out what that ending amount would be?
11.
Yep, you would take 5,500 times 2. Double 5,500 is 11,000. So that means that her ending amount, we know that her ending amount is 11,000. We want to know how long it's going to take for her to get to that 11,000. All right, so now let's go ahead and set it up. So I know that her ending amount is 11,000. And that's going to equal her starting amount. And then it would be 1 plus 037 over 12. And now we don't know t, so that's going to be a variable. So I'm going to keep that a t because we don't know what that is. So we,
Sorry.
no, I'm sorry. I took 5,500 times 2 because it says double. And if I double 5,500, I'm multiplying it by 2. Okay, so the first thing we want to do is these two numbers. So this is an actual number. We got to remember this is a number. This is a number. And this is a number. We need to break these apart. Because I need to get that base by itself. How do I break that apart? Would I subtract the 5,500? Would I add it? Would I multiply it? Would I divide it? What would I do? Divide it. So let's divide both sides by 5,500, which is going to give me 2. So I have 2 equals. And then I'll have this 1 plus. Okay. So now we need to use a log because we cannot solve for the exponent as long as it's an exponent. So the way that we get that to come down is by putting in a log. It doesn't matter which log we use. We can use a common log or a natural log. So which one do you want to use?
Natural.
All right, natural log. So let's put in a natural log on both sides. I'm going to put in a natural log. Now, in the last example, it canceled out the base, but this time it's not going to do that. What it's going to do is move this to the front. Because they're not inverses, that exponent is going to move down to the front. And that's going to give me the natural log of 2 equals 12t times the natural log of that big fraction.
I spaced out the question.
Hi. Thank you. Marsha. Says to pick something up. Okay, sorry, what's your question?
Why did you bring in the natural again?
Because we need to get the exponent to come down. So that's the third property that we talked about last week, is that when you have a log and there's an exponent, the exponent moves to multiplication. I cannot solve for t as long as it's flying in the air. I need for it to come down. So now what we need to do is to get t by itself. So in order to get t by itself, I actually have these 3 things are being multiplied. This is being multiplied by t, and this is being multiplied by t. So I need to divide both of those out. So what I'm going to do is divide both sides by 12. So I have the natural log of 2 divided by 12 times the natural log of that number. And that's going to equal time. So that is a pretty ugly fraction. But your calculator can do it. You want to type it in just like that. It has to look exactly like that when you type it in, though. So I'm going to put what the answer should be. And if you're not getting that answer, raise your hand and I will help you. But you should get, I'm going to round to the 10th place. You should get 18.8 years. So go ahead and type that in your calculator. If you're not getting that, raise your hand and I will help you. So you're gonna type in natural log of 2, and then you're gonna go down to your denominator, put 12 natural log, parentheses, 1 plus, hit a fraction bar again. Raise your hand if you got that number. Okay, so that's good. Okay, so I'm actually gonna end there, and then tomorrow we'll pick up and finish out example 6. And we'll start our first day of review. Our test is on Friday, so we'll have 3 days of review. And that's it.